So we are going to go cover today section 11.7, graphs of polar equations. We are going to cover in two sections, so we're going to do the first four examples today, and then we'll finish this next time. So copy your essential question, go ahead and copy or glue your cutout, and then unpause it once you're ready. So pause it, and we'll start once you're ready. So how do you sketch graphs of polar equations? We have polar graphs. We have several types of graphs that have equations that are simpler, much simpler in polar form than in rectangular form. One of the examples is circles. In rectangular form, we have x squared plus y squared equals 16. In polar is r equal to 4. And we're going to cover several types of graphs. We are going to cover limacons, which have the following form: Ross curves, lemniscates, and circles. Circles are the easiest one, which are r equal to a. Now, if we go into, and you can see a polar graph right below that we started doing, we started to plot points. If you go into Desmos, so take the time to go into Desmos, and we're going to start graphing. Now, one of the things that we want to do, this is in rectangular form. We have your x and your y. We have positives to the right, negatives to the left, positives up, negatives down. We're going to go into the toolbar, and here in the toolbar, we are going to go into your polar graph. Now notice that now we have your angles, and we have it on radians. We actually want to change it to degrees for today's purposes. We'll come back to radians on example 5. So we'll change it to degrees. And now notice that we have degrees from 0 all the way down to 360. Notice that we have positive 5 to the right and positive 5 to the left. Positive 1, 2, 3, 4, 5. And when you go down, it's still positive. Remember that, and we'll cover this in a few minutes, whenever, if it's 30 degrees and your r is negative, that's when you go backwards. And now we can graph. Let's go and graph. We're going to graph the limacons. So r equals, we're going to place a number for the a. Let's do 1 plus number for b, 2. Cosine of theta will be THTAT. And I change it to a different color. Red. And now we can change this to a 3, a 4, a 5, a 2. We can change this to a negative. Now, one of the things that we are going to cover, sometimes we do have a symmetry. If it's cosine, it's symmetric to the x-axis. We change it to sine, it's symmetric to the y-axis. And we actually can place a slider if you want to be able to make it a little more interesting. A, B, and then add the sliders. So we can see what happens with the value of A as it gets smaller or larger. And let's go and pause it at 2. We can actually just type in 2 or 1. And now let's change the value of B. What happens as the value of B gets larger or smaller? And we can change that to cosine. Those are limacons. The next ones are the Ross curves, and that is the type of equation that you don't need to memorize it at this point. Once you go into calculus, you'll have to find the area under the curve, and you're going to be able to need to figure out patterns. But that's way one more year. So cosine of n, and let me just type in the number for a, which will do 2. Cosine of n will be 3 in theta. We get rid of this. So those are Ross curves. Now, if we type in a 1, that's still considered Ross curves, but we want the value of n to be greater than 1. So we want it to be 2 or greater. And for this, we can, what happens as it gets bigger, we know that it's a multiply, correct? And we can actually place sliders if you want to make it a little more interesting. We can do the sliders, and we can do A. We know that's the multiply, so we want to make it a little larger so we can see it. And we can actually just make this step 1 instead. And then we can figure out, let's make this as a positive. From positive 1 to, let's say, 10. We can say what happens if it's 1 petal, 2, 4 petals, 3, 4, 8 petals, 5, 6. We have 2, 4, 6, 12 petals, 7 petals, 8, 16 petals, 7. And then from there you can start actually finding patterns, correct? Notice that if it's odd, if it's 1, it has 1 petal. If it's 3, it has 3 petals. It has 5 petals. 7 petals. 9 petals. But if you have even, it's twice as many. But then that's a different class. We're not going to go that far into the lesson. And the last one are the lemniscates. Is that how you pronounce it? Lemniscates? We'll go for that. Then I can just type in 2 cosine of theta. It's a circle, but it's on the right hand side. And then we can type in different values of A, so we know that's going to be the size of the circle. That's all sit on the right hand side. But today, we're actually going to start by plotting points. Just like whenever you cover graphing, back in Algebra 1, if you guys remember back in Algebra 1, this is my lesson from Algebra 1. So notice in Algebra 1, first we talk about your coordinate, quadrants, and that's what we did on the last lesson. Then we learn how to plot points, 3 to the right and up 2. And that's what we did on the last lesson. And then we actually learn how to graph functions by just plugging in values 0, 1, 2, 3, 4, 5. We plot the points and then we connect them. So that's where we're at right now with polar graphs. We are going to be just plotting points, and that's all we are doing. We are plotting points. So take your time to copy it down. You can either copy or paste it, your graph. So example number 3. I'm going to place and you'll need a calculator. You can use your Desmos calculator on your phone, or if you have a graphing calculator or scientific calculator as well. For today, I'm going to use my TI-84. And I'm going to plug in values for theta. And we are going to be working with degrees, just because that makes it a way easier to plot points with degrees. And I'm going to plot every 15 degrees. So we're going to start with 0 degrees. That will give me R. And I'm going to apply into the theta. Then I'm going to go into 15 degrees. Then I'm going to continue with 30 degrees. And then so on. And cosine of 0 is 1 times 3 gives me 3. But we actually can use a calculator for this. I'm going to type in 3, the cosine of 0. Now remember that you want your calculator to be on degrees. Will be 3. And then we're going to plot it. So this is 0 degrees. So 1, 2, 3, and we're going to place a dot. And then we're going to go back. 3 cosine of 15 degrees. will be 2.89. And we need just one decimal place, so 2.9 will be perfect. So therefore at 15 degrees, notice that in this case we have 0, this will be 30 degrees, we have 45 degrees, this will be 60 degrees, and this will be 90 degrees. We don't have 15 degrees, so therefore I'm going to place an extra line in there between 0 and 30, halfway mark, and halfway mark. So therefore this will be my 15 degrees. So at 15 degrees will be 12.9. So therefore this should be 3. And now 30 degrees, I'm just going to type in 3 cosine of 30 degrees. That'll be 2.6. And that's all we're doing today. So at 30 degrees will be 2.5, 2.6. And then afterwards, we're just going to connect them. Then we're going to continue with 45 degrees, then 60, then 75, every 15 degrees for this homework, 90 degrees. So at 45, so will be 3 cosine of 45, 2.12, so 2.1. Then at 60 degrees, 1.5. So at 60 is 1.5, 75, 0.8. Actually, I'm going to switch over to my Casio because my Casio is a little faster. So therefore, there'll be 3 cosine of 90 degrees will be negative. Now, careful, on this one I have it on radians, so therefore you have to be careful that I'm going to switch it back to degrees. So set up, and I want it to be on degrees. So 0. At 90, it's going to go back to 0. Then we're going to continue to, let's make another row, another table. So this will be your angle. And we're going to get back values. Once we plug it in, we're going to get back values for R. So therefore, we're going to continue at, 19, type in 0. I messed up already, right? Do you guys see it? 90, 0, 1.4. I didn't type in 75 degrees is 0.8, which is here. There you go. So you don't have to make your line, but you have to remember that you do need to be able to plot your 75 degrees. Next, I'm going to plot will be 105, then 120, 135, 150, 165, and 180. So from there, I'm going to continue with 105, and we're just plotting points. I want to add a decimal. It will be negative 0.7 or 0.8. So if you can remember, what happens if you have negative? So if it's negative 105, instead of going forward, you're going to go backwards, 0.8. Then I'm going to type in 120. So it'll be 3 cosine of 120. It'll be negative 1.5. So 120, instead of going towards 120, I'm going to go backwards since it's negative. So therefore it'll be negative 1, negative 1.5. Then it will be 135. Negative 2.1. So 135, instead of going forward, it's a negative, so I'm going to go backwards. Negative 1, negative 2.1. And then just continue. Let's see, 3 cosine 150. Will be negative 2.6. So 150 is here. So instead of going forward, I'm going to go backwards. Negative 1, negative 2.6. 165. Negative 2.89. So 165 is the halfway mark. So instead of going forward, I'm going to go back. Negative 1, negative 2.9. Then 180. Then 180 will be 3 cosine of 180. The cosine of 180 is negative 1 times 3 will be negative 3. 1, 2, 3. So it'll be 1, 2, 3. So therefore it's the same spot. And we're going to continue to 195. 3 cosine of 195 will be negative 2.89. Negative 2.9. Should be fine. So therefore, 195, which is here, well, it's actually right here. So going forward towards 195, instead of going forward, we're going to go backwards 2.9. Negative 1, negative 2.9. So therefore, that is this point. If we continue to 210 degrees, negative 2.6. So 210, instead of going forward, there's negative, so we're going to go negative 1, negative 2.6. So this one's get repeated once again. So therefore, repeat it. We are done. Now, one of the things that you have to be careful is you might want to test a few points just to make sure that correct. Or after a while, you find patterns. And if we actually graph it on decimals, if we type in 3 cosine of theta, that is your graph. So therefore, your graph starts here. We start here, it continues all the way through, and then we go through a different rotation. So once you plot it on your paper, or once you connect it, we started here, and we went all the way around. It doesn't have to be perfect. And then we went all the way around, and it repeats all throughout again. I want you guys to place arrows. I went from here, because this will be very essential as we move on to the next section and as we move on to calculus. So that is the transition or the rotation. Example number 2. We are going to plot it we're going to graph it by plotting points once again. So let's make it X and Y axis. So go and pause if you need to. Let's make it X and Y axis. So there's going to be times that actually you have to go through and do the entire 380 degrees, 360 degrees. Let's do theta and R. And we're just going to start. We're going to start with 0 degrees. Remember to place your degree sign. So therefore, we're going to type in 1, 1 minus 3, the sign of 0 gives me 1. And I'm going to apply it. So 0 degrees gives me 1. Then I'm going to type in 15 degrees, 30 degrees, 45 degrees, 60, 75 degrees, 90 degrees. And let me just go and type it in and then we'll graph each one. Makes it a little faster. I don't think you guys have the patience for me to do one. So that gives me 0.2. Negative 0.5. Negative 1.1. Negative 1.6. Negative 1.9. That should work, which is less work. Negative 2. So let's go ahead and plot them. So at 0 gives me 1. At 15 degrees gives me 0.2, so almost close to 0. Notice that's the halfway mark. At 30 is 0, negative 0.5. So instead of going forward at 30 degrees, I'm going to go backwards. So therefore your graph is going to start here and it's going to come over to the third quadrant. 45 degrees, instead of being 1.1, it'll be negative 1.1. 60 degrees, instead of being 1.6, it'll be negative 1.6. 75, which is the halfway mark, instead of being 1.9, it'll be negative 1.9. And 90 degrees, instead of going forward, it's going to go backwards, negative 2. And then we're just going to continue. After 90 is 105, 120. So 105 will be negative 1.9. 120. Negative 1.6. So 105, which is over here. I'll go backwards. Negative 1, negative 1.9. 120, 1.6, so it'll be backwards. Negative 1, negative 1.6. And notice that you start to see some of the symmetry here. And it's sine, so symmetry to the y-axis. We continue with another table of values. I'm plugging values for theta, gives me values for r. So it'll be 135, 150, 165, 180, 195, 210. After 210 plus 15 will be 225, 240. After 240 will be 255. So after 135, I'm going to go ahead and 1.1. Okay. Then 150. Negative 0.5. Then which value should come next? 0.2 probably. So 1 minus 3 sine of 165. 0.2. 180. Now just be careful. You usually just want to be able to work on a few and then plot it just to make sure that you have a nice continuation. So at 135, this is 135. Instead of being 1.1, will be negative 1, negative 1.1. 150, which is here, instead of being 4.5, is negative 0.5. Then don't forget about 165, which is here. That one's positive 0.2. And 180 is positive 1. Let's continue 195. 1.8. 210. 2.5. 225. 3.1. 240. 3.6. 255. 3.9. You start seeing some of the patterns once we continue on, but let's go and plot those points. So we left off at 180, 195, which is halfway mark between 180 and 210, will be 1.8, 1.8. 210 is 1, 2.5. 235 will be 1, 2, 3.1. 240 will be 1, 2, 3.6. 255, which is a halfway mark, will be 1, 2, 3.9. And you can imagine the 270 should be 4. So let's go and continue on. This will be R theta, and this will be R. And I know at this point you said, Diaz, I get it. I get it. But let's just continue on. So we have 270, 285, 300, plus 50 will be 315, plus 50 will be 330, 345, and last will be 360, and then we'll be done. So we're almost there. So we have 1 minus 3 sine of 270. We said that has to be 4, which it is. Let's do 1 minus 3 sine of 285 will be 3.9. 1 minus 3 sine of 300 will be 3.6. 1 minus 3 sine of 315 will be 3.1. 1 minus 3 sine of 330, 2.5. I hope you guys are doing it with me, not just waiting for me to do all the work. 1.8. 1 minus 3 sine of 360 should be correct. That should be 1. So therefore, 385 will be 3.9. 300 degrees will be 123.6. 315, which is here, it'll be 123.1. 330 is 12.5. 345 is 1.8, and 360 is there. So therefore, let's go and graph it. We started here, then we continue here. We came down over here, shot them back over here, to here, and then we came back along. So we started here, collect all the points, just like we've done when we graph lines. We basically just plot the points and then just collect them all. And we know that that is how we can actually figure out the shape of a graph. Just if you're not too sure of what the graph looks like, we plot points. We got place our arrows going towards, continue this way. And then, of course, you can say, well, hold on, Diaz, why do I have to do all the work if I can just type it up? That is an excellent question. But we need to know how everything works before we actually can. That's perfect. So therefore, if you want to be able to guide yourselves through your Desmos to make sure that it works fine, you can do that as well. But I do need to see on your homework, on your work that we're going to cover right now, what your homework will be, you do need to be able to show me the table, show me the measurements for each, the value for R for each angle. I need to see the points plotted nice and neat. I also need to see the arrows. We just need, so now let's continue to example number. So we're going to make a table of values, and this will be much, much faster. Now we learned that R equal to 4. Do you guys remember what type of shape is this? Correct, this is a circle. So we're going to plug in values for theta, which will return values for R. There's no theta. This tells me that all the values are 4. So it's going to be 4 for 0 degrees, 4 throughout. So therefore, for 0 degrees, which is here, is 1, 2, 3, 4. For 15 degrees, it's going to be 4. For 30, it's going to be 4. For every single degree, it's going to be 4. At 135, 1, 2, 3, 4. At 150, 1, 2, 3, 4. At 180, 4. 165 will be 4, 4, 4, 4, 4, 4, 4, 4, 4. And then if we can collect all those points, all the points in between, then that will be a perfect graph, which is a circle. So we're collecting all the points, and even the ones in between, it makes a perfect circle. Now for your homework today, so that was the lesson. For your homework, you are going to be print this out. Notice that I already did the work for you for graph number 2 and graph number 3. What you want to do, you want to be able to circle your birth month. So if you were born between January and March, go and circle R2 will be your first graph. Otherwise, R equal to 3, R equal to 4, R equal to 5. And then you're going to circle the appropriate graph for your last name. And for your first name, the same. Then notice that you're not going to write down graph number 1 because that's going to be a circle, just like we did. You are going to write graph number 2 here, and equation number 2 and equation number 3. So for example, for myself, Mr. David Diaz. So therefore, I'll be using this one here for my last name, and this one here for my first name. And I'll be writing them down here and here. And you'll have to do all the work just like we did right now. Now, once you are done, you are going to color it in. If you don't have color markers, I get it. There you go. So your graph will look something like this once you are done. If you don't have color markers, then you can just shade it in different shades of gray. Then you're going to take a picture and upload it to Google Classroom, and that will be your homework. Basically, you are doing 2 graphs. Remember that you are going to write down every single measurement for R. Have a good day, and I'll see you guys next time.